Imagine a massive solar storm hits Earth tomorrow, and wipes out every power grid on the planet. Ancient geometry still works. The stars are still readable. Water still flows downhill. But your smartphone, your hospital, your food supply chain, gone. Here's why one civilization's science survives any catastrophe, and the other collapses the moment you pull one wire. The paradox nobody talks about. We have been taught, almost as a religion, that progress moves in one direction. Forward. That everything we build today is stronger, smarter, more permanent than what came before. And by most measures, that is true. We have more computing power in a single phone than NASA had when it landed men on the moon. We have mapped the human genome, split the atom, connected 8 billion people in real time. So the idea that ancient science could be more resilient than modern technology feels almost offensive. It sounds like the kind of thing someone says at a conspiracy forum, or in the opening chapter of a bad fantasy novel. But here is the uncomfortable distinction that changes everything. Resilience and advancement are not the same thing. They are not even close to the same thing. In fact, they frequently work against each other. The more advanced a system becomes, the more it depends on everything else staying perfect. And the more it depends on everything else staying perfect, the more catastrophically it fails when something goes wrong. That is not speculation. That is engineering. And that is exactly where the ancient world had a structural advantage, that we have never fully acknowledged, and are only now beginning to understand. Section 2, the seed versus the clock. Think of ancient science as a plant. You can cut it to the roots, burn the branches, scatter the seeds to the wind. But if even one seed survives, in the memory of a traveling scholar, in the oral tradition of a remote village, in a manuscript hidden in a monastery in the mountains, the plant grows back. Because everything the plant needs to rebuild itself, is encoded in the seed. It doesn't need a supply chain. It doesn't need a functioning government. It doesn't need international cooperation. One seed, one mind, locally available soil. Now think of modern technology as a clock. Not a simple clock with 12 parts. An impossibly complex clock with 10 million moving parts, where each gear was designed by a different engineer, in a different country, manufactured from materials extracted across a dozen continents, assembled under conditions that require precision measured in millionths of a meter. The clock runs perfectly, when every gear stays in place. But if 3 specific gears in the middle break, the entire clock stops. And you cannot carve replacements from wood. You cannot improvise them from local materials. You need the exact gear, machined to exact tolerances, produced in a factory that itself requires hundreds of other specialized inputs to function. If the factory doesn't exist anymore, the gears don't exist. And the clock stays broken. Not for years. For generations. That single difference explains almost everything that follows. Section 3, How Ancient Science Actually Bounced Back. Let's look at the historical record, because this isn't theory. The Library of Alexandria burned more than once. The Roman Empire collapsed, taking centuries of engineering knowledge with it. The Black Death killed a third of Europe in less than a decade, including thousands of scholars and craftsmen who held technical traditions alive. Entire cities were abandoned. Entire languages died mid-sentence. And yet, within 1 or 2 generations, in almost every case, the knowledge came back. Not because someone had the foresight to back it up. Not because a perfect archive survived somewhere. Because the knowledge was rederivable. Geometry doesn't change because a library burned. The stars don't rearrange because a civilization collapsed. The principle that water flows from high to low, that a lever multiplies force, that stone placed correctly carries enormous weight, none of that disappears when the civilization that first documented it falls apart. A person with a rope, a stick, and a clear sky, can rebuild the foundations of ancient science from scratch. That is not romanticization. That is literally what happened. A scholar in Baghdad in the 9th century looked at the same stars Ptolemy observed centuries before, and reconstructed Greek astronomy almost entirely from first principles, without a copy of the original text. Medieval monks in Ireland, who had never seen Rome, copied mathematical texts they barely understood, and those texts later seeded the Renaissance. The knowledge bounced back, because the knowledge was local, observable, and fundamentally human in scale. Anyone with a mind and the right materials could find their way back to it. Modern technology has no equivalent of that seed. Section 4, the Silicon Bottleneck. Let me make this concrete, because abstraction is easy to dismiss. Right now, modern civilization runs on microchips. Every system that matters, power grids, hospitals, water treatment, food distribution, financial networks, military communications, depends entirely on semiconductors continuing to function. And making a modern microchip is arguably the most complex manufacturing process in the entire history of human civilization. A single fabrication facility for cutting-edge chips costs tens of billions of dollars to build. The machines inside use ultraviolet light at wavelengths shorter than the diameter of a virus, to etch circuits into silicon with a precision that defies ordinary intuition. The lenses inside those machines are made by one company, in Germany. The lasers come from another company, in California. The silicon wafers are processed in Japan, Korea, and Taiwan. The rare earth elements come from mines in a handful of countries, some politically unstable. Now imagine any serious disruption. A prolonged conflict. A cascading grid failure across 3 continents. An extreme climate event that breaks supply chains for 3 consecutive years. The factories pause. Chip production stops. Existing chips continue degrading, because semiconductors were never designed to last forever. And here is the part that deserves to stay with you. Nobody alive knows how to rebuild that entire production chain using only locally available resources. The knowledge of how to maintain our civilization has been distributed so widely, across so many hyper-specialized domains, that it no longer fits inside any human mind. Or any 10 human minds. Or any 1,000. We have, without quite realizing it, outsourced the knowledge of how to run civilization, to a system so complex that it can only maintain itself when everything is already working. A Roman aqueduct engineer understood, from first principles, everything required to build an aqueduct. He could teach it to an apprentice using locally available stone, and the simple observation that water flows from high to low. The knowledge was human scale. Ours is not. And that gap is growing, not shrinking. The information paradox. Here is the layer of this problem that almost never gets discussed. We believe the digital age is the great age of preservation. Everything is recorded, backed up, stored in the cloud. We tell ourselves we are safer from catastrophic knowledge loss than any civilization before us. But consider this. The Rosetta Stone is over 2,000 years old, and you can read every word on it today with nothing but your own eyes. The Dead Sea Scrolls survived 2 millennia in a desert cave, without power, without maintenance, without any infrastructure keeping them alive. Now consider what happens to a hard drive, unpowered for 20 years. The magnetic charge that holds the data degrades. The bits flip. The files corrupt. Not dramatically. Not with fire or smoke. Silently, invisibly, the data simply ceases to be readable. Now scale that up. A modern data center, if its cooling system fails for 72 hours, can lose everything stored inside it. Every photograph, every medical record, every scientific paper, every piece of music, every historical document. Gone. Without ashes. Without smoke. Without even a mark on the ground to show that something was once there. The entirety of human digital knowledge requires electricity, every hour of every day. It requires cooling without interruption. It requires maintenance by trained engineers on a continuous schedule. It requires international cooperation between companies and governments and infrastructure providers, simply to remain intact. Remove any of those for long enough, and the greatest library humanity has ever assembled vanishes. At least when Alexandria burned, people saw the fire from a distance. They knew something was lost. They could grieve it. A catastrophic server failure leaves nothing behind to mourn. Just dark rooms, full of metal boxes that no longer spin. Built for eternity versus built for Tuesday. There is one more dimension to this, and it cuts deepest of all. It's not about infrastructure. It's not about supply chains. It's about intention. About what a civilization believes technology is actually for. The ancient world had a concept, present in Egypt, in China, in Mesoamerica, in medieval Europe, that the alchemists called the great work. The idea that the highest purpose of craftsmanship was to create something perfect. Something that would outlast the maker. Something permanent, not as an accident, but as a deliberate goal. The pyramids were not built to be replaced. The Pantheon, standing in Rome for nearly 2,000 years without a single restoration of its original dome, was not designed with a maintenance contract. The aqueducts that still carry water today, in Spain, in North Africa, in the Middle East, were built by people who expected them to exist long after everyone involved in their construction was dead. And there they are. Now look at the philosophy embedded in modern technology. The average smartphone is designed, deliberately, not as an unavoidable consequence of rapid innovation, but deliberately, to become non-functional within 3 to 5 years. Not because engineers couldn't build something more durable. Because a more durable product is a less profitable one. Planned obsolescence is not a flaw in the system. It is a feature. Engineered into the product from the first sketch. And it has infected not just hardware, but the entire cultural logic of how we build. Tractors controlled by encrypted firmware that farmers legally cannot repair themselves. Medical devices locked to software that manufacturers can remotely disable. Appliances, tools, industrial equipment, all dependent on digital systems that can be rendered permanently non-functional by a corporate decision made on the other side of the world. We have built a civilization that produces miracles and engineers them to stop working. The ancients built for eternity. We build for next quarter. The knowledge monopoly. Here is something that rarely gets named directly. In the ancient world, knowledge was certainly not democratic. Priests guarded their astronomical calculations. Guilds protected their structural secrets. But there is a fundamental difference between knowledge that is guarded by a guild, and knowledge that is structurally impossible to access without a billion-dollar industrial ecosystem. A medieval stonemason could, in principle, share everything he knew with any apprentice who showed up at his door. Two minds, directly, without any intermediary system. Modern technological knowledge is increasingly non-transferable at the individual level. The engineer who designs a processor architecture cannot explain to a motivated student how to build one from scratch, because that student would need a factory that doesn't yet exist in their reality. This creates a new kind of monopoly. Not a monopoly of secrets. A monopoly of infrastructure. And in the ancient world, if a guild collapsed, another could form. If an order fell, a student who had memorized the principles could rebuild from the ground. In the modern world, if the fabrication ecosystem collapses, the knowledge of how to rebuild it is distributed across so many specialized domains that no single reconstruction effort could gather it all in time. The knowledge doesn't live in minds anymore. It lives in systems. And systems, unlike seeds, cannot grow back from a single surviving fragment. What would actually survive? So let's ask the real question. If a catastrophic but non-extinction level event disrupted global infrastructure for a decade, which knowledge survives, and which stays behind? The answer follows directly from everything we've built here. What survives is what is local, observable, rederivable from first principles, and human in scale. Basic hydraulics, because water still flows downhill. Structural engineering built on the principles of load and compression, because gravity doesn't change. Astronomy, because the same sky that guided every civilization before us remains unchanged, patient, available to anyone who looks up. Fermentation, the ancient basis of medicine, food preservation, and fuel production, because microbes don't require supply chains. Mechanical engineering at the level of levers, pulleys, wheels, gears, basic metallurgy. These are exactly the domains where ancient science was deepest, most refined, and most thoroughly stress-tested by catastrophe after catastrophe. What stays behind? Digital communication networks. Semiconductor-dependent energy infrastructure. Modern pharmaceutical supply chains requiring cold storage and sterile manufacturing. GPS and satellite navigation. Precision industrial manufacturing at every level above basic metalwork. Every technology that requires a functioning global network of specialized inputs to remain functional. This is not pessimism. It is just what happens when you follow the logic of complexity, all the way to its natural conclusion. None of this means we should abandon modern technology. The gains we've made in medicine alone have saved hundreds of millions of lives that ancient science would have lost. The point is not that ancient science was better. The point is that it had something we quietly traded away. Resilience. And here is the thing about that trade that is almost invisible until you name it. Efficiency, which is what modern technology maximizes, is the natural enemy of resilience. An efficient system has no redundancy, no slack, no margin for disruption. It runs perfectly when every condition is ideal. The moment one variable slips, it fails completely. A resilient system is inefficient by design. Multiple ways of doing the same thing. More stored than immediately needed. Functional even when parts break. Ancient science was resilient because it had no choice. There was no global supply chain. There was no maintenance system that required 40 cooperating nations. Knowledge had to be local, teachable person to person, buildable from what was directly around you. That constraint, which looked like a limitation, turned out to be a profound source of durability. The kind that allows something to be burned to the ground and grow back from a single seed. We tend to look at history as a march from fragility to power. But maybe what we've actually built is something enormously powerful and profoundly brittle at the same time. And the question worth sitting with, after watching this, is not whether ancient science was better than ours. The question is, what are we building right now that would survive us? Because the geometry is still there. The stars are still there. The water still flows downhill. All of it, patient, rederivable, waiting. Long after the servers go dark. If this made you think differently about something you assumed was solid, share it with someone who needs to hear it.